Hello everyone, welcome to today's tutorial. Have you ever wondered how your computer actually works? What's going on behind the user-friendly interface? Today we are diving deep onto chapter 2 of our series on operating system. We are going to break different types of operating system, peek under the hood at their architecture, and see how they manage file, process, and memory. Let's get started. First up, let's talk about the types of operating system. Operating systems are the backbone of your computer, managing both the hardware and software resources. They are the foundation of computer functionality. There are three main types of operating system we need to know. Number one, Windows. Among personal computer, Windows is the most commonly used operating system. It's known for its user-friendly interface, and it has a wide range of software compatibility. Many popular applications are designed especially for Windows. It is a go-to choice for a lot of home and business users. Number two, we have a Linux. It is an open source operating system, meaning it is a free to use and modify. Linux is highly customizable. It's favored for its security and stability. Popular distributions of Linux include Ubuntu, Fedora, and CentOS. If you are into programming or server management, you have probably heard of Linux. And finally, there is a Mac OS. This is Apple proprietary operating system designed exclusively for Mac computers. It's known for its sleek design and seamless integration with other Apple products like iPhone and iPad. If you are in the Apple ecosystem, Mac OS make everything feel connected. Now that we have looked at the type, let's dive into architecture of the operating system. The architecture is composed of several key components. Kernel. The kernel is the core part of the operating system. It manages systems resources, including memory, process, and hardware devices. Think of it as the brain of the operating system. Then we have a shell. The shell is the interface that allows user to interact with the kernel. This can be through a command line interface or a graphical user interface. Without the shell, you would not be able to give comments to your computer. Then we have a file system. The file system manages how data is stored and retrieved on a storage device. It organizes files into directories and subdirectories. Then we have a device driver. Device driver are software that allow the operating system to communicate with hardware peripherals. These include printers, graphics cards, and network adapters. Without drivers, your hardware would not function correctly. Now, we are going to talk about the file system and storage management. File systems are crucial for data organization and retrieval. Different operating systems use various file systems. NTFS stands for New Technology File System used by Windows. It supports large file encryption and security features. Then we have EXT, stands for Extended File System. It is commonly used in Linux. Various Version like ext3 and ext4 provide robust performance and reliability. Then we have APFS, stands for Apple File System. It's utilized by macOS. It offers improved performance, reliability, and encryption. Storage management involves organization data efficiently. This ensures data integrity. It includes managing partition and allocating storage space and implementing backup solutions. Now we are going to talk about the process and memory management. Efficient process and memory management are vital for operating system performance. Let's break it down. First, we are going to talk about the process management. The operating system must manage multiple running processes. It ensures fair CPU time allocation. It handles process prioritization and scheduling. Imagine having 10 tabs open on your web browser. Your operating system decides which tab gets to load first. Second, we are talking about the memory management. Memory management involves managing the system RAM and virtual memory. It's ensure efficient utilization. It's avoid issues like memory leaks and fragmentation. Techniques include paging, segmentation, and memory caches. This ensures your computer runs smoothly. By understanding this concept, you gain a deeper appreciation of how operating systems function and their critical role in the computing ecosystem. So thank you for this tutorial. Once again, I will hand over the multiple choice question based on this tutorial. So you should able to answer all those questions. Thank you.